Bacteria can be found in a wide range of environments. In addition to their adaptability, they are also some of the hardest living organisms on the planet. Some bacteria also have a very interesting range of abilities. Maybe like some cyanobacteria that can make their own food directly from the sunlight. These microscopic beings are everywhere, from the tip of our fingers to the depth of our existence. Some have evolved to coexist with other organisms, whereas some can cause even fatal diseases. Welcome to Facts of the Fact. Metal Mouth. But before that, we need to know what is bacteria and virus. Is virus and bacteria the same? Of course not. Bacteria are single-celled living organisms. They have a cell wall and all the components necessary to survive and reproduce, although some may derive energy from other sources. Viruses are not considered to be a living because they require a host cell to survive long term for energy and to reproduce. In current we are seeing corona. Recently scientists have discovered a type of bacteria that eats and gets its calories from metal. After suspecting they exist for more than 100 years but never proving it. Now microbiologists from the California Institute of Technology or Caltech accidentally discovered the bacteria after performing unrelated experiments using a chalk-like type of manganese. Dr. Jared, professor of environmental microbiology at Caltech, left a glass jar covered with a substance to soak in tap water in his office sink and left the vessel for several months when he went to work off campus. When he returned, Dr. Lead found the jar coated with a dark material. Researchers discovered that the black coating found on the jars was oxidized manganese, which had been generated by newly discovered bacteria, mostly like found in the tap water. These are the first bacteria found to use manganese as their source of fuel, although such microbes were predicted to exist over a century ago. Manganese is an essential nutrition for all of us. Our bodies use it for things like processing fats, proteins, and bone formation, and we get that from foods like nuts, teas, and leafy greens. The researchers say the bacteria's cell doubling times and rates of oxidation would create manganese oxides in amounts equivalent to global reserves in just 2 years. Close relatives of these species seems to be present in many places, so their potential to cycle these metal across Earth could be vast. Scientists believe the findings will help them better understand groundwater and water systems which can become clogged by manganese oxides. Manganese is one of the most abundant elements on the surface of the earth. Manganese oxides takes from the form of a dark, clumsy substance and are common in nature. They have been found in subsurface surfaces, deposits and can also form in a water distribution system. There is a whole set of environmental engineering literature on drinking water distribution system getting clogged by manganese oxides. The finding helps researchers better understanding the geochemistry of groundwater. It is known that bacteria can degrade pollutants in groundwater, a process called bioremediations. When doing this, several key organisms will reduce manganese oxide, which means they donate electrons to it, in a manner similar to how human eye oxygen is in the air. Scientists have wondered where the manganese oxides come from in the first place. The bacteria we have discovered can produce it, thus they enjoy a life cycle that also serves to supply the other microbes with what they need to perform reactions that we consider to be beneficial and desirable. The research findings also have possible relevance to understanding manganese nodules that dot much of the seafloor. These round metallic balls, which can be as large as grapefruit, were known to marine researchers as early as the cruises of the HMS Challenger in the 1870s. Since then, such noodles have been found to line off the bottom of many of Earth's oceans. In recent years, mining companies have been making plans to harvest and exploit these nodules because rare metals are often found concentrated within them. but little is understood about how the nodules form is in the first place. This discovery from Dr. Gerard and Hank Phillips is a major intellectual gap in our understanding of Earth's elemental cycles, and it adds to the diverse ways in which manganese, an obtuse but common transition metal, has shaped the evolution of life on our planet.
Hope you have enjoyed the video. Like the video, share to your friends and subscribe for future videos.